All right. Cool. That works. So let me know. Make sure it doesn't fall over. Thank you. All right. So that's that. Okay. So this is the last one. Okay. So we decided that everything I pulled out except for the stick is a computer so far, right? This is the last one, and this is gonna be the trickiest one. What is this? Anybody tell me what this is?
A light bulb.
It's a light bulb, right? Everybody knows what this is. Raise your hand if you think this is a computer. Okay. Raise your hand if you think it's not a computer. Okay. Josh, why do you think this is a computer?
Because it's you can plug it in like any other device and it charges, so that's why I think it's a computer.
Yeah, it does charge. Like light bulbs turn on. You're right, but this is a very special light bulb. Because this is actually a computer.
I knew it.
Oh my goodness! What?
I thought it was some computer, but you said it wasn't you.
You did not. Josh was the only one that had his hand up.
No,
All right, fine. I'm sorry.
Nobody else besides me and Paloma.
Yes, we'll go to the video later, all right? Relax, guys. So, let me explain what the computer in a light bulb can do, okay? A computer in a light bulb can sit there and listen and get instructions from another program. And it can sit there so I can get on my phone and my light bulb can be screwed in at my front door, for example, at home. And I can install a program on it that says if it notices that my cell phone is within 10 feet of the light bulb, automatically turn on. So if it's dark at night and I need to open my front door and the light's not on because I didn't turn it on when I left the house, now it's automatically going to turn on whenever I walk up to my front door. And that's what a computer is. It's a program. It's got a little bit of intelligence, just a little bit. It's like a third grader.
What?
Just kidding. I wanted to see if you're paying attention. And you were. Lael, do you have a question?
It's a comment. Now that I don't think all light bulbs can do that.
You're absolutely right. Not all light bulbs can do that. But more and more we're seeing what's called a connected device. There's pretty much anything you can buy for the house nowadays is going to have a computer in it. Your blinds on the wall are going to have a computer in them that can sense when it's sunlight outside and automatically open when it's sunny and close when it's not sunny. Your sprinkler system outside can have a computer in it that says, you know what, it rained yesterday, so I don't have to turn on for the next 3 days. We're good for a while. There's a lot of things. Your thermostat can have a computer on it so that it says, you know what, it's really hot today. I'm going to automatically turn on to cool off the house for when everybody gets home and it's nice and cool. Isn't that kind of cool?
Yeah.
So guess what that means? If there's so many things that are going to be coming out that have computers in them, what kind of jobs are people going to need to do in the future, do you think? Programming, exactly. They're going to have to write a computer program. Now, I'm sure every single one of you, if I know my kids, I'm sure everybody else is doing this too, uses particular computer programs all the time.
Oh yeah. Oh yeah.
You want to take a guess at what that program might be?
Yes.
Video game.
Mackenzie.
Video games.
Video games, exactly.
I was gonna say apps.
I was gonna say your brain.
Apps, sure, that could be.
Your brain. Google. Your brain. Google Space.
I don't even know what that means, so no.
Your brain.
But, right, so kids play games all the time. So if you want to be a programmer, you want to make games, you could do that. Or if you want to be a programmer and do, I don't know, like productive things, you could do that too. So there's a lot of things you could do as a programmer. What I was originally going to do in this class was kind of show you guys how to create a program like Minecraft. But when I started putting it together, it got a little bit complicated because you guys have kind of a short attention span. It takes a long time to learn how to write that program all together. So I thought about, does it make sense to break it up into a lot of classes?
Yes.
But I think what might make more sense is to kind of give you the overall structure of how do you write a program. So let's go and do that real quick, and at the end I'll show you a Minecraft that I wrote on my computer real quick. And it looks a lot like the regular Minecraft. And if you write the program yourself, you can create your own creatures, for example. So you can has anybody here not played Minecraft before or know what Minecraft is? Does anybody here not know what Minecraft is? Okay, so Minecraft, real quick, is a computer program, and it's a game. And it's a really cool game, because in the game you can do a lot of things. What you're basically doing is you see a world, and you can look around and you see the world, and you see trees, and you see sheep, and you see ground, and you can break things. Sure. So you can take all these things, these are all kind of ingredients that you can mix together to make new things. You can build a house, you can build a spaceship, you can build whatever you wanted to build. So that's basically what Minecraft is. So in the mod that I was able to create, different creatures. So I could create a pig that could shoot arrows out of its mouth. So you can just think of whatever you want to think of, and you can create it. You can create your own Minecraft mod. But let me show you real quick what you have to do to write a program. So let me put this away real quick. I don't want to break this light bulb.
Do those also change colors too? Those light bulbs?
This particular one doesn't, but they do have those.
Got one that he can control just.
Yeah. See, the problem with that is that the light, the ones that.
Boys and girls, we have a speaker in here. If you want to continue listening, you're gonna have to close your mouths so we can hear what he has to say.
So the light controlled ones, I think, are a brilliant idea, especially for outdoors. Because I would love to put tree lights in, and like St. Patrick's Day, make them all green.
Yeah.
And Christmas, make them red and green or something like that. But the ones that change color aren't outdoor safe yet.
Okay, yeah.
This is definitely indoor.
Yeah, the video
only,
you showed us was all like inside stuff. Or
right.
It could be like to music, and it could be to
sure, absolutely.
all kinds of stuff.
It's really kind of cool. But yeah, Philips was the first one to do it, but there's a lot of companies that are doing it now.
Yeah.
Do you have a question?
I have a comment about the light bulb.
Sure.
We're gonna let's hold comments to the end.
That's what Miss Fellow does. But I have a question.
Do you have a question or a comment?
Go ahead.
A question.
Okay.
Doesn't a light switch have a computer in it? Because I don't know really know how a light switch works. And I think it's a power cable, and then there's like a little camera that communicates to the light.
Yeah, it is. It's not really a program though. It's actually more like if you think about a water pipe, right? So you've got a faucet, and there's water all inside that pipe. And what is turning that faucet do?
Make the water run.
It lets the water come out, right? That's basically all a light switch is doing. It's just a regulator that's saying the electricity could come to the light bulb, but I'm going to shut it off so there's no electricity that can get to it. That's all it's doing. It's just a physical switch. It's not a program. It's not thinking. It's not really a program.
So does it mess with your switches when your phone is activating the light to come on? Like those kinds of lights, can you still work with a switch, or it can only work with your phone?
No, you can do both. Yes. Now there's a main power. So if you shut off the main power, the phone's not going to do anything because there's no power flowing to the bulb itself.
So as long as
exactly. Some of the outdoor ones I believe are going to be coming out with batteries as well, so they don't have to be plugged in. You can have a garden light that has its own battery pack. It can even be solar powered, so it can run by itself.
Whoa.
So let's go ahead and write a quick program. I need a volunteer that I haven't picked yet. Thank you. So what I'm gonna do is let me write down first of all what I need a program to do, and I need a volunteer that I'm gonna pick. You can put your hands down for now, to tell me what are all the steps to do the activity, okay? So the first program I wanna do is I wanna build a robot, okay? And the program that's gonna run inside the robot is gonna be a program that's gonna make the robot, let's pretend the robot is one of you guys, and it's gonna make you guys,
It's around the crazy people.
walk
on
to the window
Then jump out.
Yeah, I do.
and sit back down. Okay? So let's come up with what we need to do. What's your name with the greenish shirt on?
Jameson?
Jameson?
Yeah.
Jameson. What's the first thing that this program would have to do?
It would have to be attracted to light, since the window usually has light.
What's the first step for a robot? If you were a robot, what's the first thing you would have to do to do that? To walk to the window and sit back down? Just let's say you're a human being. What's the first thing you'd have to do?
You would have to walk. You would have to start walking to the window.
Okay. Okay, so he missed a step. Anybody tell me the step that he missed? haven't picked yet. Philip.
You need energy to do it.
You need energy, that's true. You do need to have energy to do it.
Electricity.
Sure. It doesn't have to be electricity, but you're right. You do need some sort of energy source. So let me make that a 0 item. You need energy.
-1 item.
We might end up there. Okay, you need energy. So let's assume that somebody has energy. What's the next thing they would need to do before they can start walking to the window? Riley.
They have to face the window.
You have to face the window.
They have to face the
Okay.
window.
Okay, so let's make that a 0.5 then.
0.5.
Face window. I have terrible handwriting, but hopefully you guys can read that. Now we missed a step before 0.5. Well, we're running really short of numbers here. Let's pick somebody I haven't picked yet. Blue shirt. What's your name?
There's a chair.
Jacqueline. It's gray, isn't it? I'm sorry. Go on, Jacqueline.
You have to always stand up.
Stand up. That's the step I was looking for. Very good. Let's make that a 0.25. Stand up.
Writing a computer program.
Nice. C++?
It was going to be Java, but we'll see where we end up.
Cool.
So the first thing we got to make sure we have energy. Then we need to stand up. Then we need to face the window. Then we need to start walking to the window. I feel like you're going to need to pee if I don't let you pick. So go ahead.
Build it, like build the robot.
Oh yeah. The robot's already built. So we're working on the assumption that it's already built. It's sitting here. All it has to do is we have the right program to make this robot that's already been built by somebody else get up, go to the window, and sit back down, right? So I think we can go past step 1 now. Have we missed anything? Anybody feel like we missed anything up to here? Molly?
You had to look out for a little while.
To look out of the window. Well, it's not really an instruction. It just says walk to the window and sit back down. So you could make the program do that as well. But for now, this is all we wanted to do. Forget your name. I know you told me. Jada? No.
Maddie.
Maddie. Sorry. I'm sorry.
That is Jada.
That's Jada. Yes, I'm sorry, Jada. And Maddie. Did I miss anything? Well, you don't have to raise your hand if I didn't miss anything. All right, let's assume I didn't miss anything. Let's go on. So let's back up. Okay. So what's after walking to the window? What's the next thing I have to do? All right, go ahead.
Turn around.
Turn around. I like that.
Yeah.
I'll leave some room in case we forgot a lot of stuff there. Probably did, but let's assume he's right.
I don't think Minika will need to turn around. She's already facing the window.
And I don't even need it. All I have to do is sit here.
I don't understand what that means.
Exactly.
Here,
We need
What?
to make some ground rules. First of all, you need to only speak if your hand was up and you're called on. What you're calling out has nothing to do with what we're talking about, so you have to stop it.
We're not talking about where you're sitting in the room in proximity to the window. We're making a computer program, so you need to think about the overall purpose of what we're doing. All right? Everyone work for the common good of what we're doing.
So we got to turn around. What's your name in the white shirt? What is it?
Yeah.
Diaja. Go ahead.
Then sit back down.
Then sit back down. Okay. Turn around and sit back down.
You missed
I'm gonna leave a lot of room here.
We missed.
Anybody have anything else that I haven't picked on yet in the black shirt?
Jasmine.
Jasmine, go ahead.
We missed this step. You have to walk and then sit down. Walk to your seat, then sit.
I like it. I like it. 2.5. Walk back. Because what would happen if we just went from 2 to 3? Where would we be sitting?
At the window.
At the window, exactly, right? So it seems really obvious to write a computer program, but there's really a lot of steps involved in writing a program, right? Now, in fact, if we just look at one little part of the steps, there's a lot of steps here. So this whole thing is a program, and it's great. But this particular one is the one I'm interested in. The .251 is stand up. I need another volunteer. Okay, before I pick the volunteer, I want you guys to do me a favor, okay? As soon as I pick the volunteer, I need everybody to look at this person and pay close attention to exactly what they're doing. because what I'm going to need this person to do is to demonstrate what standing up is. It's very, very hard. So I'm going to need somebody to demonstrate it. So let's go with Miss Hildebrand.
Okay.
All right, everybody pay attention to Miss Hildebrand. She's going to stand up for us. That was well done. How about a round of applause? That was great. Okay, thank you, Miss Hildebrand. That was great. That's perfect. I need, just to compare, because not everybody stands up the same way, I would like one other person, and I'd like everyone to pay attention to this person as well. Okay?
Which one am I standing up?
Sharon?
Adrian.
Adrian, I'm sorry. Adrian. I'm sorry. Okay, so everybody pay attention to Adrian. Go ahead, stand up, buddy. Okay. Did anybody notice any differences between Miss Hildebrand and Adrian in the way they stand up? Toby.
Miss Hildebrand had to rock back and then get up.
Had to rock back and then get up, okay?
I'm in a rocking chair, all right?
Hey, I had to get up and look for a second. I was like, we're at the rock back?
I'm not quite that old yet, but
That's right. You have to say, while you're doing it too. That's what I do. Okay, I need one more difference. And I'm only going to be picking people that aren't talking in between, just so you know in the future. Omari? Hey, look at that. I don't think I've seen you since kindergarten.
No.
Go ahead. Can you think of another difference between the two of them? In the way they stand up?
He didn't use his hand.
He didn't use his hands. Okay. Okay, so that's good. That's good. We don't need any more differences. The reason I wanted to point this out to you is because there are different things you can do to stand up. So you got to kind of think about, how do you want this robot to actually stand up? Do you want it to swing its feet around and then stand up? Do you want it to rock back and then go? Because you might build this robot with weapons on its head or something. That's going to make it very top heavy. It's got to make sure it's balancing properly so it doesn't fall over as soon as it stands up. So there's a lot of different things you got that stand up entails, right? So remember that every one of these is going to break up into a lot of tiny little instructions. You got to think of a program as a really, really not intelligent person, because you got to break it down to say exactly what you want it to do, otherwise it's going to do the wrong thing. For example, if I told a robot to walk from here to, and if the only instruction I gave a robot was to say walk from here to the cafeteria, what's the robot going to do when it gets to that door?
Just run and smash into itself.
I didn't see a hand. Jada, go ahead.
It would just keep running into the door because you never told it to open it.
That's right. It might break the door. It might damage itself. But I got to be very specific and tell it what to do, right? And then what about in these instructions? We have very specific instructions here where we told the robot, we said, you need energy, stand up, face the window, start walking to the window, turn around, walk back, sit back down. So if these were the only instructions, and let's say that one day the robot gets up, starts walking to the window, and there's a desk in the middle. The robot's going to say, I don't know what to do. It's just going to keep walking into the desk. So you got to make sure that you can program for things that might happen that you didn't think about ahead of time. A really interesting story for you guys. Does anybody know, I'm going to describe something to you. Tell me if you know what the name of this thing is, okay? It's at the bank, and people take money out of it. Wesley. West, sorry, West.
Safe.
A safe? Yeah, you can take money out of a safe. I was thinking of something else that you put a card into. Jake.
I was thinking of mailbox, but now I'm thinking like an ATM.
ATM, that's exactly what I was going for at the bank, right? So there's an ATM at the bank, right? So what's one of the things that an ATM program has to do? If I put my card in and I say, hey, ATM, I'm gonna go to go pick up lunch for my kids, so I need $500. Because they eat a lot of food. And what's that program, what's one of the things that program has to do? Go ahead, Philip.
It's gonna like bring out $500.
Okay, that would be a program for a bank that's going to lose a lot of money. Because what should it do before it gives you the money? Can anybody think of something it needs to check? Molly?
Like the numbers on it.
Check the numbers on your card. Make sure it's right. Make sure that you put in the right password. Sure. What's something else it might need to check?
You need
Jasmine?
yes. You need to check if you have the if you have enough money.
Make sure if you have enough money. Exactly. What if you don't have the money? That's just going to give you somebody else's money. Well, it could. It's a pretty awesome program.
Maybe it makes
Oh yeah, it would.
But it's probably not going to do that. So there's a lot of little things you got to write to make sure your program is going to work correctly, right? Now, the reason I'm talking to you guys about this is because remember the fact that just in something simple, that seems simple, like stand up, there's a lot of stuff involved in something like that, right? So what if we had to write another program, okay? This time, the robot's job is not to stand up, walk to the window, come back and sit back down. This time, the robot's job is going to be to, let's see, to come get a marker and sit back down, okay? Let's just, I don't have to, we might as well write it down. So give me the first step. Brandon?
Yeah.
Go ahead.
Pick it up, the marker up.
Pick the marker up. Okay, I'm gonna put that way over here.
Think about if you were where you are right now, though, and you needed to go pick that marker up. What would you have to do? You have to do a lot of things before you do it.
Jake, go ahead.
First you need to stand up.
I like it.
We're taking everybody's ideas.
How is that 0?
I'm a mind reader.
This is less than 1. Jada, go ahead.
You need to walk to the whiteboard to get the marker.
I like it. I didn't pick you yet. What was your name? James. Go ahead, James. What's next? What will be next? Is that what you were going to say when you had your hand up? Okay. Can you think of anything else, or did I miss anything? Go back to seat. Sure, we can add that later. Anybody else? Okay, Josh.
Avoid anything in your path.
I like it. I like it. So maybe that would be part of walk to the whiteboard, right? So let's just add it in here.
White
Avoid. Let's make it line 0.51. Avoid things. Okay, so that's good. But remember that stand up is a lot of things. You have to write down exactly how you're going to stand up, how you're going to balance, and all that stuff. So if I have to write this program over again, guess what I have to do? If it took me, it might take me 3 days to write the program just to make it stand up.
Whoa.
So then later on, if somebody comes back and says, now I need you to write another program that's going to do all these things, it's going to take me 3 days again to write that program to make it stand up again. So what programmers do, they use a really cool trick. And the trick they use is they take a set of instructions and they throw it into something called a package. And a package is really, it's called a lot of different things based on what language. H-E. It can be called a package, it can be called an object.
Or a box.
Or a box. If anybody remembers the class I did last time, I called it a box. But an object is just a set of instructions. And so then what I could do is I could create a package called stand up. And if anybody had a robot anywhere in the world and they needed that robot to stand up, they wouldn't have to spend 3 days writing every single thing and maybe missing some of the things that I thought of. And all they have to do is to use my package, my stand up package. And the stand up package can actually have additional things. Does anybody here know what an adjective is?
You're actually doing that in grammar right
I
now.
know. I'm like, why
Really?
is everybody's hand not up?
Yes. Oh, I want to say Nick?
Yes.
Yes, awesome, thank you.
It describes a noun.
An adjective describes a noun, I like it.
I was going to say the opposite.
Is that good?
That is excellent.
All right, thank you. I didn't want to speak for you. So describes noun. Okay, so basically I can add adjectives to my package. And one of the adjectives I could add to it could be speed, right? So I can let the person that's using my package determine how fast is this thing going to stand up, right? And then I would say things like, well, when the adjective that you want to use is going to be a number from 1 to 100.
5,000.
So it's describing, right? It's describing what this is going to be. So for example, when I use this to stand up, and I'm going to call this adjective speed, and they can pass in whatever they want the speed to be from, let's say it's going to be from 0 to 1,000. So let's say, for example, it's going to be 50. So if it's from 0 to 1,000, 50 is way down here, it's probably going to be pretty slow when it's standing up. That way we're sure it's not going to teeter-totter. But if it's something that the Army's going to use for a soldier robot, they might want to set it to 1,000, it's going to stand up real quick. And then maybe fall over. Does that make sense? So that's what a package is, and that's how a computer program works. Is that you just write out every single instruction you're going to need to write out, and whenever you want to be lazy, you go use somebody else's stuff. Does that make sense?
Yeah.
So that's kind of I think that does a pretty good job of describing. Oh, you know what? There's also maybe related. Does anybody here know what a verb is? What's your name in the black shirt? Karina, go ahead. You're the one whose brother looks like Whit.
Yes.
Is that right?
Yes.
Okay, gotcha.
A verb is an action word.
Action word. We good? Yeah. All right. Action word. I like it.
Jasmine is.
Okay. So let's say, for example, that I'm writing a program for Minecraft. Okay. And let's say that I create a new creature in Minecraft, and this object is going to be my new creature that people can include in their mods, and they can start using this creature now. So let's say that my creature is going to be called it's a mix of a pig and a frog. It's going to be called a prog. Right?
Cool.
Okay? And instead of an adjective, I can also have a verb or an action that this object can perform. So give me an example of something in this world that a prog is going to be able to do. Brandon.
It can jump 5,000 feet high.
It can jump. I like it. Okay? Jump. That's a good verb. So this creature can jump. Now there's a problem here. So when a creature jumps, let's think about yourself. Forget about a creature. In real life, right? If I told you to jump right now, could you do it?
Yeah.
No.
Yes.
Who says yes? Raise your hand if you say yes. Raise your hand if you say no. Why do you say no?
You have to get up.
You have to get up. You might have to get up first, unless you want to consider that part of jumping. But let me take it a step further. Suppose you were jumped out of an airplane. You're wearing a parachute, and you're coming down to Earth with a parachute on, and you jump. What's going to happen?
You're not gonna go up.
Nothing's going to happen because you're falling. You don't have anything to push against, right? Does that make sense? Suppose you're floating in the ocean. You're treading water out at the beach, and you jump, and you're way too far from the ground. What's going to happen?
You're not gonna jump.
Probably not. You're probably going to splash a little bit, right? So one of the things that describes the jump might be, where are you when you're jumping? So where is this creature? Is the creature in the middle of the water?
No.
Is the creature up in the air? Is the creature on the ground? You have to decide, when is it going to do what?
On the lily pad.
Lily pad. That might be tricky, but I guess.
You
Sure.
have the body of a frog and the head of a pig.
Okay.
What
you say? So that's about. Yeah, you probably want to be on something solid when you jump, but you could have other things happen even if you're not on something solid. Like if you were in water, you could make it splash.
You can make
You could do other stuff that's not really jumping, but it could do something. Philip, go ahead. Do you have a question or?
The frog is good to eat.
It's good to eat. Maybe.
Not a question,
That
honey.
might be. Does anybody have a question? No. Okay. Okay, Josh.
Why is it not good to jump on something that's solid?
It's not that it's not good, it's like you can't do it. You don't need to push off of. Are you? I mean, come on, bud.
Yeah, but a lily pad's not that solid, but frogs can jump.
If you can really give that as an example, let's get something that you can keep with the lesson.
So basically, computer programming is, to me, it's a lot of fun. There's a lot of creative things you can do with it, and pretty soon there's going to be a lot of jobs for it. Actually, not pretty soon. Right now, a lot. So if we're hiring, so if anybody's interested.
I'm interested.
And put your hand down, Miss Bell. You're not going anywhere for a year.
When they say like games have like come a long way, is it because they're getting more detailed in what they're telling, like from 1 to 2 now there's like 5 steps in between to make it look more real that the person's getting up out of the chair than like very robotic?
So there's multiple parts to that answer. So you're right, games are way ahead of the Atari I used to play when I was a kid.
Yeah, right.
And the reason for that is multiple. One is this whole concept of, it's called object-oriented, of building things as an object and letting other people use it. Or packaging it just for yourself and letting yourself use it, so you don't have to redo all the work
So people
again.
are specializing in smaller things and then
Exactly.
sharing.
So like there's a whole industry now of programmers that don't actually produce anything. They just build the objects for other programmers to use. So, you can basically not know anything about programming, and if you know the right stuff to use from other people, you can build something and charge somebody $100,000 for it. Like a government healthcare website maybe. There's all kinds of stuff that you can do with programming that's very, very easy nowadays because you don't have to go to the level of detail. It obviously helps because if something breaks, you're like, how do I fix this? I bought it from somebody else. I don't know how it works. It's like a car, right?
Yeah.
My car runs great. I know how to use it. But if my car breaks down, I got to take it back because they're all computerized now. I don't know how to do any of that stuff. And then the other thing is the hardware. So the hardware is improved that it's running on it. The software is running on as well. So now you've got this level of detail that's phenomenal. It looks like like a real life, like when you're walking through a hallway. If you played any of like the
Sims and all that.
yeah, the Sims are pretty good. But I was thinking of the some of I mean, they're not really kid-appropriate games, but there's a lot of these like war games and stuff where there's like, it's really realistic. It's incredible.
Lots of
Lots
clams.
of detail.
No, that's not.
Yeah, it's not really realistic, but it's but the quality on that game is incredible. You're right. And it's simple. It's important to remember who your audience is. You got to keep it simple.
So is your job, do you do more of the packaging or are you at the... Or
No,
like
we're a software company that builds a software that we charge clients for. So we have our own software. So we have a development team. And then kind of the interesting thing being a programmer nowadays, so like if you're trying to think of a job, if you're a pool cleaner, right? If you're a pool cleaner, you're going to go to a pool, you're going to clean that pool, and the people that you work with are probably going to be people in the office, the people that you're buying chemicals from. If you're a mechanic, the people you're working with are probably the other mechanics that are in the shop, maybe the dealership, if you're working at a dealership, something like that. Something really cool about my job, being a computer programmer, you can do it from anywhere. So at my work, on my team, I've got people that are working at the office with me. I've got people that are in another country called Ukraine. That's pretty far away. We got people working in Oregon. We got people working in Texas. And then we all have, we all get on the computer and we look at each other and we have meetings every day with these people that are all working on the same thing. So we can see exactly what code everybody else is writing and we can test it. And you're communicating with them every day. And I think it's really cool to be able to talk to these people. It's a little tricky sometimes because sometimes their English isn't that great. But but it is interesting, definitely. Did you have a question or?
Question.
Go ahead.
Can you work at home or you usually work at?
That's a good question. I'm fighting with my boss on that one right now. So I could work from home if it was allowed. So there are a lot of computer programming jobs where really, because you're able to do this stuff over the computer, you could do it from home. But really, like I tried it for a while myself, and I know that me personally would not be good at that because there's a TV too convenient to me.
So do they want you to and you really don't want to do it, or?
Yeah, I think it would be a good idea to be able to work from home once in a while, just because I gotta wait for somebody to come fix something or whatever. I gotta make a doctor's appointment, and it'd be easier than having to come to work and then go and stuff. But then obviously there's the whole factor of, well, am I actually gonna get productivity out of you? Are you gonna be, if I can't watch you, I don't know what you're doing. So
They're leaning towards not letting this happen.
it's open. We'll see what happens. So go ahead.
when you're talking to other people in different countries and states, do they speak English?
Yeah, so the people that we work with have to speak English because I don't know, I was terrible at languages. I took French 1 for 3 years. But they have accents, so, you know, sometimes a little bit hard to understand, but sometimes they're really, really good. So, you know, computer program is mostly math, and so if you're good at math, it doesn't matter what language you speak. Good question?
Can you make
So be good at math.
Can you make the the robot or something speak a different language?
Sure, you could do like a language could be an object that you create. So you could be a language object, and then other people could use your language object in their robots. And then you could have a French one or whatever, maybe to interpreting language. There's a really cool device. I don't have it anymore, but I used to have these things called Google Glasses. And they're kind of cool. Where all they are glasses that you wear that have a little computer on them. And it projects a little screen in front of you. And the coolest thing about these glasses is that when I was traveling, when I was in Mexico, does anybody here speak Spanish?
Everyone should be using that. Everyone should speak.
Everyone should speak Spanish? Okay, so I guess not everyone here is comfortable speaking Spanish, but maybe everybody here knows it. So if I'm traveling to another country, does anybody here know French? A couple of you know French? Okay. Okay, if you didn't know French and you went to a French restaurant and you're looking at a menu that's in French, would you know what the menu said?
No.
You wouldn't know what the menu said, right? But guess what the glasses I had could do? The glasses I had could look at the words on the page that were in French and automatically make it English. So as long as I was wearing the glasses, I could read it in English. It was so cool.
Oh my God.
Like I could look at street signs and I could read the signs in English. And like, if it says do not enter, I don't know what that means in French.
Where
So
are
we're
they
in
now?
Italy. What's that?
The glasses.
I sold them.
Oh.
You can get them for cheaper next year.
No, you could buy packs for different language conversions. You could go English to French, English to. They have it they have iPhone apps.
Did you make it?
So that was the biggest problem I had with the glasses is that everything I could do with the glasses I could do with the phones. I didn't really see the advantage of it. Because it's called Word Lens. It's really cool.
That is pretty cool.
But you just hold it over like a menu or whatever, and you walk around the phone. It's pretty much the same thing, except the glasses were $1,500. They weren't cheap, but I was able to sell them for more, so I went ahead and bought them.
So what language did you get it basically for? What were you needing to read?
This was when we went to Italy and we went to Mexico and Belize. So French and Italian. Yes. Apparently pizza is still pizza in Italian. Who knew?
So you probably could have got away with it.
That's right. I didn't even need this app. Right. Did you guys have questions? Go ahead. Leo?
Is there something that can translate, like someone's saying, like if someone's speaking Spanish and you have no clue how to speak Spanish?
Sure. Do you know what something called Siri? Have you ever heard of Siri?
Oh, yeah.
This is for Lil. Lil, do you know what Siri is?
Yes.
What is Siri?
Siri is something that is on like the iPads and phones, and it like search things on the web.
Sure. So it's just a program that's on a phone, a lot of Apple devices, and you can talk to it and it'll do things based on what you're talking to it. Do you think everybody in the world speaks English?
No.
So do you think Siri needs to be able to understand other languages?
Yeah.
Yeah. So in other countries, Siri can speak other languages. So it's kind of cool
I can
that
you can change it.
you can change the way
you can
Siri.
change it on settings.
Oh, all right. Well, thank you for sharing and for being smarter than me.
It also activates Siri by just saying, "Hey Siri," and it activates.
Oh, really?
Yeah, if you
gotta be
go
annoying.
under settings and
Okay.
if you go under settings.
But what if you had a friend named Siri? Then your phone would keep answering you.
Hey Siri. Hey Siri. Hey Siri. No, not you. Hey Siri.
So what's funny was where you can tell Siri what to call you. So I told Siri to call me Mr. Awesome, and I didn't realize that it automatically updates my contacts to put Mr. Awesome in as my nickname. And I sent my contact over to somebody at work, And they were like, I'm gonna call you Mr. Awesome. I was like, sorry, I didn't know it did that.
Last night I programmed Siri to because it kept saying, all right, moms, and I don't know how I mixed it up, but it was calling me moms. So I put in my name. I was like, Siri, please call me Katana. And then it connected to Katanya Fowler. And then it was like, so I said, Siri, who am I? And then Siri said, you are Katanya Fowler. But since we're friends, I'm going to call you Katana.
That's cool.
No, I was like, what?
Yeah. So I'm gonna real quick show you guys something on my laptop, so we can maybe
Do you want to project it?
let's do. Yeah, that might be easiest rather than having everybody come over. Do you mind if I'm sorry. I know I said earlier not to. I didn't
Listen, real quick. Pardon me, guys, real quick. You want one of these chairs right here from Vikram to West. Sit on the floor.
Debbie has that, you know what?
Vikram to West. Just sit on the
Has
floor.
that thing that we'll do Riley. You know that Debbie has Riley. Debbie has that thing call me say this. Hi.